Hello class, this will be a review of physical science chapters 4 and 5 by using the daily questions to review for the test. So first we talked about the atom. This is chapter 4. Identify and describe the parts of an atom. So we have protons, neutrons, all inside the center, which is called the nucleus. And then we have these electrons out on the energy levels. So being able to identify those parts, you'll definitely need to know that. Explain energy levels of electrons and the ideal number of electrons that atoms need to be happy. So energy levels are the location or kind of cloud where electrons are found, and the first energy level can hold 2 electrons. The second can hold 8 electrons. And then the third goes to 18 and so on, but we're really worried about that number 8. 8 is stable, okay, after that second energy level. Define valence electrons. Valence are outermost electrons. They're the most important because we talk about them when they bond. They are important for bonding, determine chemical properties, and they are shown in the dot diagram. So if we look at this next thing, dot diagram, these will show valence electrons only. So hydrogen has 1 outer electron. Carbon has 4 outer electrons, and oxygen has 6 outer electrons. So those are some examples of what diagrams look like. The next day we looked at the periodic table. So groups, they go up and down on the periodic table, numbers 1 through 18. You should have those labeled on your periodic table. Periods go across the periodic table, and there's numbers 1 through 7. Make sure you have those labeled. The group is things that are in the same group have similar chemical properties. And with that, then we also know the number of outer electrons. A carbon atom. So we're going to practice drawing them. So a carbon atom, we are going to have six protons. Neutrons are also equal to 6. That's in the nucleus. First energy level, 2 electrons. Second energy level, 4 electrons. That's our example of the drawing of the carbon atom. If we want to look at chlorine, we'd have 17 protons, 18 neutrons in the nucleus. First energy level, 2 electrons. Second energy level is full. You have to fill that energy level before you can move on. And so that would be 8 there. And then the third energy level has 7. 1, 2, 3, 4, 5, 6, 7 to get us to 17 electrons. All right, then looking at ions and isotopes. So first thing we want to look at before that is that the atomic number is equal to the number of protons. The mass number is equal to the number of protons plus the number of neutrons. Protons in general equal the number of electrons in a neutral atom. And then the exceptions to these are ions and isotopes. So ions are a charged atom. And how we know that it's an ion, the proton number will no longer equal the electron number. So electrons change. Oh, right here, let's put this up here. The atomic number is the identity, so the proton number can never change. If it changes, it's a new atom. So question 2, when does an atom become an ion? When it loses or gains electrons. Why does an atom become an ion? Is in order to become stable, to bond in an ionic bond. Define isotope. So isotope is when the mass changes, and the mass cannot change by the proton number because the proton number has to stay the same to be that particular atom. So what happens is the number of neutrons changes. So if our neutrons are different than what we should normally get, then it would be an isotope. So how we know it's an isotope? The number of neutrons is different. What is a common characteristic of an isotope? It's radioactive. They don't all have to be radioactive, but a lot of them are. So families of elements, looking at the periodic table, which groups are the most reactive? Groups 1 and 17. And why? It's based on their valence electrons. Where are metals on the periodic table? The left side. Where are nonmetals? The right side. Semiconductors along the stair-step line. And the man-made elements above 92. Which group is stable the way it is? Noble gases. Group 18. They don't need to bond with anything. They're happy the way they are. All right, looking at compounds. So define compounds. Compounds are atoms that are chemically combined. They're not mixed together. They're actually chemically combined. Why do atoms form compounds? To become stable and fill their outer energy level. Explain why the properties of an atom are different than the properties of a compound. So we talked about this quite a few times. When atoms are by themselves, they have specific properties, but when they combine with something, their properties change. The example we used was sodium and chlorine. Sodium is toxic, chlorine is toxic, but when we combine them chemically, they become table salt, something that you use all the time on your food. And that would be a fine example. Differentiate between ionic bonds and covalent. So ionic is a transfer of electrons, and covalent is a sharing of electrons. What are oxidation numbers? Oxidation numbers tell us the number of electrons that are given away or taken in an ionic bond. How do you know an atom's oxidation number? From the valence electrons. Also on your periodic table, because we wrote those on. But if it has 1 through 4 outer electrons, it gives them away. 5 through 7 outer electrons, it takes on the number, it takes on as many as it needs to get to 8. And polyatomic ions, they are groups of atoms bonded covalently that pretend to be an atom and bond ionically as well. You have these on your periodic table, and if you don't have them on yet, make sure you have them before the test. All right, making compounds. So with making compounds, we're looking for the oxidation number, and then we're going to do the crisscross method, switch the oxidation numbers, and drop the positive and negative. So as our example here, magnesium is +2. When we say that it's a positive oxidation, that means it gave away that number of electrons, so it gave away 2 electrons in this case. What does a negative oxidation charge mean? We'll show that in chlorine. Chlorine is -1, so it took 1 electron in that case. So if we're going to make a compound with these, we have magnesium as +2, chlorine is -1. We're going to trade the 2 and the 1 and get rid of the plus and minus, and our formula is MgCl2. You could also show this with our drawing. So Mg has 2 outer electrons, chlorine has 7 outer electrons. Magnesium will give that one away, but it still has 1 to give up. So we have another chlorine atom that it gives that to, and so you can see we have Mg1, chlorine 2. What exceptions are there when making a compound with a polyatomic ion? There's not really exceptions, it's just that when we see a polyatomic ion, like SO4 2, if we're going to put it with something like Na, we don't change this number. That 4 stays there. You could even put parentheses around it so you know don't change it. And what happens is we have Na2SO4. So we just make sure that we don't get rid of the number that's there. Maybe we have another one like aluminum sulfate. Aluminum is a +3. SO4 is a -2. You can put parentheses around it again just to make sure you don't mess that up. It'd be Al2 SO4 3. So there's 3 SO4s that are involved in that particular bond. All right, naming compounds. So the steps to naming an ionic compound: name the first element, and in the second element you change the ending to IDE. So example here, it would be magnesium chloride. We change that ending to IDE. What exceptions are there with a polyatomic ion? You just leave the name as it is. You don't change a polyatomic ion's name. And then Roman numerals are used when you're showing a transition metal. So tin to bromide would be an example. This Roman numeral is telling you the oxidation number for that transition element. And that's the review for chapters 4 and 5. Make sure you can identify an atom, that you can find protons, neutrons, electrons. You can draw them, you can do dot diagrams, and that you can show how to make a compound and name a compound.